Welcome. Thank you.
Thank you. This is a very high-level talk, but it's very technical, so I won't cover the details, but I will show you the most important things. Please be aware I use these two terms. I say music and audio is in different kind of sense. I will show you why. So the point is, in the past, we used to have, I still remember when I was in high school, I played the Apple II, whose ancient, very, very tiny machine, worse than your smartphone. Actually, it's worse than your, IoT device. A single computer handle all these kind of things in one software. However, because we have more and more software and hardware power, so usually we want to process not only the raw timbre or texture, auditory texture, let's say the piano sound will be dun 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 dun, then you have the courses, like the human voice, or these are two different kind of texture. I would say this is the auditory things. And however, in music, then you can have, say, the pitch. Let's say this do, mi, so, and you play three things together, you have a C chord, C major chord. So please bear in mind, even I say C chord, do, mi, so, right? But for different kind of timbre, like say the piano and the vocal voice, they can be the same ratio, but with different kind of texture. In music production or some kind of, let's say, even game playing, we need to deal with both of them. And later, it maybe have some kind of complicated thing. Like say, right now, the new media is popular. If you go to some kind of the club, maybe they will just pop in this kind of flash this light together with the boom, 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 boom. So you have a very complicated audio and visual signal synchronized together. So we start to need to have a good system to make this both of these kind of things synchronized. So later, because it became so complicated, we start to think about, can we use several software to work together rather than just in the past just use single software. So my talk will around this kind of issue to get better things. So basically we'll discuss how this sound system works in the past and following the latest development. So if most people here, I think they use Linux, but we have the new sound system called PipeWire, have a more feature than the previous, like say ELSA, which if people got the sugar, let's say ELSA probably the first generation, the old sound system, maybe 40 years, right? Or 50 years, okay. And the later, the post audio is popular, it's very powerful, but the PipeWire have some more nice features. And the last part is we'll talk about cross system, not only working inside the Linux. Sometimes you need to, especially in the music industry, sometimes you need to work with some musicians. They only use Mac, or some people only use the Windows. So it's good to stick with the Linux, but you need to have to be flexible to work with them. So how can we solve this problem? So in the past, we have some kind of acoustic instrument, or you need to use, let's say, MIDI to connect this something. So remember I said, since the MIDI is box, they deliver two things. One is the timbre, like say the piano sound or the guitar sound or human voice, and the pitch. These are two different kind of signal. So the texture, how should I say, the timbre is by this digitalized PC and waveform, And then you have this control. Let's say this is 16 channel for the MIDI 1 and 2, and you can assign the first one will be grand piano, the second one will be drum, something. I'm not quite sure the guitar or something like that. And you say, okay, the first note will be C major for less than 2 seconds. It could be the 2 beat, something like that. And you can also extend this idea into the OSC to control more things. Now this is the first generation, so you have, like say, several box, maybe the mini box. They use this kind of thing, which is like the very old PC keyboard connect to it, and then they are in some kind of daisy chain one by one, so you can transmit this timbre from the first one to the last one, or you can say, okay, I want the first one play this timbre and let the last one play another timbre. And later they have a USB bridge to replace this kind of old cable. And so once we have this kind of network, it's not really the RJ45 network, it's kind of communication between this kind of device. Then we have 2 different kinds of scenarios. One is the IPC. You have intra-computer communication, I say 2 software talk to each other. Or sometimes you have, let's say, the inter-computer or inter-box communicate to each other. In this case, when I say it's actually use the UDP or UDP-IP multicast, it's kind of modern network sense. However, if I have a 10 MIDI box, I don't want to remember, oh, this is the 92.86.0.1 is piano. It's too tedious. And I don't want to have domain name server to remember. So this is something called zero conference configuration network. They both available in, like say, Mac OS, Windows, and also Linux. So they will give you some kind of very easy name domain name service. So you can say, oh, the first one is called guitar. The second one is called, I say, pipa, which is a Chinese instrument. The third one could be piano, something. So they give you some name lookup things without you to figure out this name entity. In Linux, we have this Vishi. I'm not quite sure about it, how to pronounce this kind of thing. The first one is, I think, is invented by Mac, Apple. So the Windows, the Bonjour is available on both the Windows and the Mac OS platform. And so once you have this network, the instrument, you can use certain software to help you to measure that. In Linux, you can use the QMIDI MED or RTP MIDI. So you can see this. Use this RTP protocol to facilitate this kind of communication. Now we go to the modern world. Because we have a better and better hardware communication, so we try to do certain things more complicated. For example, we really want to using this kind of software to do the AP to AP level interprocessing. I will discuss this later. For example, in the past, we have a MIDI software. We put in certain, we use a mic to record my voice, and okay, let's say, okay, this one, I want to this, the output done. But can you, to using, like say, only my high voice to deal with certain low voice? No, you have to save this result and plug into the input again. If there's something can let you to deal with the intermediate result, that'll be better. That's something I call the AP to AP interprocess. So the Propello head is software company. They have this reward. They just try to solve this problem. So they have this software can pass the intermediate result from one software to another one. So but they still in a very ancient form. So they have one single host can reach several devices. each one have this panel, so control the parameter of the device. So the partial or temporal computational result from one device can pass to another one. So if you are familiar with Linux, it's like in the ancient time we don't have this mouse keyboard. The only thing you have is the keyboard or the punch card, which is the standard in to your computer, and the standard out is screen. But Linux, Unix, actually, we can train these things. We call it pipelining. So you can take whatever things as the input, let's say some output of this C, feed into the input of A, and output it to the A to the B, something like that. So this way is actually is AP to AP label intercommunication. So I give you an example here. This is something in Bash. You can echo. This is in Linux or Unix. Okay. You also you can do it in the Mac or the Windows subsystem of Linux. So you can echo a string, pipe into another thing to do that. In this case, I try to grab a number. So in this case, there are 5 people here. Go through these 2 subprocesses, I will get the number 5. And I can make some kind of manipulation later. So in this case, for example, if I use my mic to record my voice, right? So I can feed into this software. Also they have this interprocess capability. So I can use the DAW, let's say, Audio or Audacity to record some of my voice and feed into the Sphinx or Whisper, which is the AI, AST, which is automatic speech recognition, to find this word, like say, though I say some bunch of English, they can find something like say there's 5 people and trap the textual information I need. In the same time, because I have a voice, right, I can feed into the pure data, so use as the texture or timbre, like the guitar, and feed into the MIDI, and I can specify the pitch or duration by this textual information. So I don't know whether you guys can realize that. I'm trying to get an analogy about these 2 things. In the past, this cannot be done, but right now we have a computation power to do this something. So actually we can realize this pipelining in text in the auditorial processing right now. So there's an even advanced processing. I think starting by Mac OS, they have a program called Siphon, which uses the GPU to feed into to gather the to receive the input from something, process it, and output it to another one. This one is very powerful because they realize the AP to AP interprocess within GPU, so it's very fast, almost no delay. Well, the debate is not only delay, but the delay is so small, so you cannot notice. You are thinking about, oh, let's just passing through the kind of things. And later they have a spouse in Windows doing similar things. But there's a constant pro because in this case they use the GPU, so the latency is very slow. So you can do a lot of things. But however, if you encounter this situation that you need to transmit your data from one machine through network to outer machine, then you have a problem. But there's some kind of way to do something. The latency is not so bad, but it can go through the network. Now the system, this is not so ancient system. I think it's let me see. Pulse audio. This is the one before the PipeWire. So you can see they can using this zero conf module to pass this some information through the network, and they also have a very how to say that comparable layer, like say OSS, which is very old, sound system or ELSA, to deal with some things, and they also can talk to the node or GTK things. And in that time, actually, they can do certain things, I say, the employer to talk to certain AV things, but they can actually do certain video things, but performance is not so good. So if you using this one to deliver audio together with a video, the CPU loading is very high. Now, let me see. Now, later we have this PipeWire. I think the Red Hat guy, they reinvented this kind of thing. If you guys know there's a thing called GStreamer, they are the OSes are the same. So they rework on this idea not only to do the AP to AP level auditorial processing, they also include the video processing. And because guys, recently we have this overhaul about the X system, so we have a WLAN, and because the security issue is mechanism is different, so they need to have another layer to deal with this kind of thing. So right now, under the new Windows system in Linux, this PipeWire, the performance was much better than post audio. Even though you can still use post audio to do the same thing, but the performance of this one thing will be much better. Of course, if you have done this something, you will notice there's another famous sound system called Jack. Jack is more toward to the musician work, so the critical part or the focus is on the low latency. So it's so if you need to have, let's say, the live session, the latency is so critical, because if there's a little bit delay, I can hear that. So my performance will be interfered by a small latency. But sometimes if you just watch the drama or from the Netflix, you don't care about a little latency. So Jack is probably not something you want, because the configuration is very complicated. And post audio is something in between, but I would say I'm not quite sure the PipeWire will beat post audio in every consideration, but I think for the long run, the PipeWire will replace the post audio, just like say post audio replaced ELSA 10 years before. Now, I just show you an example here. By having this AP to AP interprocessing capacity, we can do something very complicated, like say have a voice using some recording, DAW feed into pure data to use as the timbre. In the same time, I can using some kind of machine learning or AI program to extract this textual idea to feed into sound control. So the single task to play the music or extract something can be very complicated, because you can think about it. If we have let's say 5 or 10 different kinds of software, the interconnection is very complicated. So right now this is some kind of software called session measurement or patchback help you to measure this kind of interconnection, because each time you can have a different kind of connection. For example, right now I'm using this mic, right? If I go to my car, I may start to use the Bluetooth earphones. So the configuration of this mic can be dropped if I go to enter my car. Similarly, if I leave my car, maybe I need to add this kind of thing. So this need to these kind of things will be better if you have a session manager to help you to save the profile. Oh, this time I should use this microphone, I should use this speaker. So these are some popular choices you can use if you use Linux. I mentioned that the PipeWire, also PipeWire is also the also of the G spinner, and you can do similar things. Use this video. Let me see. Video for Linux 2 loopback, but I would say PipeWire will give you the better integration because they also take care of the WLAN the security issue. So if you have your preference, that'd be fine. Like say using jack or post audio, there's no problem. If you are new bit, you don't know which one to start with, I will encourage you to use the PipeWire. And later, once you have this kind of AP to AP interprocess things, not only you can do with the audio, we can also use it in the video. For example, if you guys could probably notice OBS. OBS is a software to let you to overlay different kind of things. For example, I'm doing some kind of a talk, but I'm in a very my background is too messy. So I can replace this kind of a thing. And similar things, if I want to play the song during my talk, but this mic is too noisy, actually I can reroute a recording sound directly to the live session without using my noisy mic recording. So this kind of AP to AP interprocessing is very important. I will foresee that since right now we have so many abundant AI power, we can add more complicated things depending on your demand. Later, if you need to work with Linux sound system with other OSes, you also have another choice. But however, since you no longer do the intra-computer processing, that means you have inject certain delay between this network communication, right? No matter what's Linux to Linux or Linux to the Mac or Linux to the Windows. So you expect that the latency increase. So you will lose certain things. Like for example, you probably cannot use the jack because jack is targeting for you to working with the intra-computer things. There's a toolkit I recommend. Rock toolkit is for Linux. If you want to use Linux to talk with the Mac or Windows, you can use NDI. I will follow a talk about little the plugin a little bit. So, for example, we know there's a VST, which is some kind of interface or plugin. There's another thing called VSTI, is the instrument of VST. Like say, the MIDI only specify, okay, the channel 1 is something like a piano or a guitar. But whether this is acoustic, whether this is the Steinway piano or let me think about some fancy, expensive piano, Yamaha or say that again? Stanford, okay, yeah. Or Bowman, which is popular in jazz. They are all piano, but with different kind of timbre. So the VSTI, the VST instrument, actually give you the digital sampling about particular one. And so this is in the Windows part. But in Linux part, you also have this LADSPA, which is some kind of interface in the first generation. And for last generation, you have a DSSI. But later, they have a second generation, so they merge these two into the LV2. So, as I mentioned that you have some wrapper, you can wrap the VST2 or OU or something into the LV2. But he is a better person to ask because I don't touch this so much. So, what does that mean? That means that if I need to play the song with 100 different kind of timbre, which is too much for my computer, but I can use the network to send to 100 different kind of computer. Each one only respond for one timbre. That can make it work. Because for the grand piano, like say the Steinway piano, I think they at least use a 2 gig RAM. For 1 or 2 piano will be fine, but 100% you will be something like 2 gig times 100, maybe 200, will be too much for a single computer. But in this way, you can make these things work because right now you have a distributed sound processing capacity. So this roughly my talk because this is some details. I'm not quite sure you guys can dive into that thing, but I think I have a few minutes and you can ask a question or give me some feedback. So basically my talk is just ending here. Thank you.
Thank you. So for networking, what kind of like plugins and mechanism there is? Because I know on Jack there was something to do some network process, but on PipeWire I never tried. I actually do a lot of like audio music creation with Ardor on Linux. Before I used Jack and now I use PipeWire, and I use external audio interface for the latency issues. And so I'm wondering what kind of tools are currently used for like so networking for audio processing. Yeah, thank you.
Actually, it depends on your application. Like I said, if you're a musician, your network environment allow you to have not so serious latency. I will encourage you to use a jack. A jack is kind of complicated. You need to know. Make this kind of patch back to connect this kind of input-output, right? But if your latency is good enough to use a jack to work, I would recommend jack. There's certain thing like say, I'm working on some proposal. They have, this complicated, they have a huge 8K display and 64 or 128 speakers. And if you need to control that kind of things, you probably cannot use a single computer to control. You need to distribute this computation into maybe 4 or 6, how to say it, the master node or something like that. They use a network to go through. In that case, I'm not quite sure I can use the jack because the client is working on the Windows. I need to find some way to fit in their requirement. That's the reason I mentioned the NDI, because NDI is the protocol they have the software available for Linux and Windows, the Mac, and the client I'm going after is using the Windows. So I may have to work with them using NDI for my Linux server to talk to some kind of node, use NDI and talk to the final the client. So it's not necessary in this way, but in my case, I have to work with my client, so I have to do this kind of thing. But it's not necessary. It's not necessary. Does that answer your question?
Jack we can do with Jack. NDI is something compatible with Windows, but if we just want to work between Linux machine with PipeWire, what should we use?
I'm not quite sure. I mean, well, if you're just talking Jack, I'm not quite sure Jack can deal with the video things. But if you're using post audio can deal with both audio and the video. My guess, if you working with the audio and the video, you cannot use the jack because jack doesn't support the video processing. But post audio and PipeWire can deal with both audio and video. Does that make sense?
Okay, but for the networking settings for PipeWire, how do you do to like distribute audio?
Very simple. You create a node, output a node, which is, and then in your patch bay, you specify this network node is some kind of sink, which means you send out your input to the particular port. So for that kind of things, scenario, a speaker or network port, they are the same. They are like just like the Linux STD out. They are just output device. From the internal realization, they are just the port. Physical one, they are different because, like say, in intra-computer things, this two output port can be the program inside the same computer. But in this case, we use a network which is intra-computer. The source is in one computer. The destination is different kind of computer. But for us, for user, they are the same. But if you encounter certain things, like say you are a network engineer, you probably will to calculate the latency, whether it's or bandwidth is good enough. Because if the bandwidth or delay is too much, even at work it will have some kind of very bad sound to generate it, and then you want to avoid that kind of thing. But you need to have test. But ideally they are the same. So this kind of thing is nice because they put this very high level abstraction. So you think about everything just port. It's either input port or output port. But physically they could be different.
I think we have one more question. Yeah.
What is the biggest change from pulse audio to PipeWire?
Good question. So actually they are very similar, right? So I would say that I guess the major issue is about the change of the Windows system from the X Windows system to this WLAN. Because the way they change the Windows system, you cannot just I think in the past the X window is so-called network transparent. You can just send something to the remote computer directly. Right now you cannot do that kind of things. WLAN is no longer network transparent. You need to go through the security sandbox or something like that. So for the new Linux, the only way to transmit this audio to another computer doesn't work. You need to go through the security mechanism, and the PipeWire is designed to bypass this issue from the very beginning. So you can see this, the yellow ones here, and they can use the container and the thread part. I'm not quite sure about the implementational detail, but this is critical one. Another thing is, I think because Bluetooth is popular recently, they do certain improvement about something, but I'm not quite sure about detail. But for this kind of things, this kind of enhancement, so I told you that the workload of the dealing with the transmission of the video, the PipeWire will be superior than pulse audio a little bit. But if you don't have this PipeWire, you can still use the pulse audio to deliver audio and video together. If you just deliver the audio, I think they are almost the same, except for this security issue. I think from what I have heard is these three are most important. I think the Red Hat guys, they have this PipeWire just in less than 3 years, or I'm not quite sure. It's pretty new. But I was told that most of the new distro, start to teach the PipeWire. They start to teach the post audio and choose PipeWire as a default sound server. So that means that if you just download the latest Red Hat or something, what's that? Fedora, the default server could be PipeWire. Yeah. So. Say it again. Yeah. So, I guess that's the price for you to embrace the new technology, right? Associate, did you have something to talk about this?
Yeah. PipeWire has an adapter for pulse audio, so you can actually use application that is based on pulse audio on PipeWire. There's a wrapper around it, so you don't have to worry about that. I don't think you have to rewrite your code. That's all what I meant.
No, I think he's right. I mean, the user just want to go to the new the next situation without learning something. Even to rewrite the configuration is kind of burden for them. They try to learn as little as possible.
Do actually people need to write any configuration for pulse audio?